A very good afternoon to all of you students. So students, after completing 13 lectures related to your second chapter, that is electrostatic potential and capacitance, probably this is the last lecture, lecture number 14. This is the last lecture for your second chapter, electrostatic potential and capacitance. And students, from all of you, if anyone required any video regarding a particular topic regarding this chapter, then inform me. I will try to make a video regarding your topic. Okay, so lecture number 14 is related to important theoretical problem. If you go back to your previous exam paper, previous 10 years exam paper, then you can see these types of questions, and the questions are, that is, we have to calculate the effect of dielectric on various parameters. That means first question you have to given that you have a parallel plate capacitor which is charged by battery, then the battery is removed. Find first of all parallel plate capacitor charged by a battery, then the battery is removed and a dielectric slab is inserted between the space of the parallel plate capacitor. Then the question is, you have to find out what will be the changes, the value of charge change or not, the value of capacitance, the value of electric field, the value of electric potential, the value of electric potential energy. So this is our first question, and the first question is, first of all you have given a parallel plate capacitor which is charged by a battery, then the battery is removed. Then you have to find, and after that the dielectric slab is inserted between the space of the parallel plate capacitor, and you have to find out the changes, that is the effect of parameters, effect of dielectric on various parameters. And the second question is, a parallel plate capacitor is charged by a battery and the battery remains connected, not removed, and again a dielectric slab is inserted between the space, between the separation of two parallel plate capacitor. Then you have to find out the changes. So first question, case number 1. Case number 1, that is battery removed and dielectric inserted. Okay, suppose there is a positive plate, this is a capacitor, positive plate, and this is another the negative plate, minus, and this capacitor is connected, this capacitor is charged by a potential, that is V. Okay, you can write this is V naught, initial condition. Now for this potential developed a charge here, that is plus Q naught, and here that is minus Q naught. Now the question is, then you have to this potential is removed. Okay, remove it, this potential is removed, and a dielectric slab is inserted between this plate, and a dielectric slab is inserted between these parallel plates, this total separation obviously. Okay, write it down, this one, that is the dielectric slab is placed between the total separation, that is D. Now question is, you have to find out the changes, charge, potential, electric field, electric potential energy, etc. Okay, so when we introduce a dielectric slab, what happens? Here induce a negative charge, here induce a positive charge, and for inducing this negative and positive charge, here induce an electric field EP which is directed plus to minus, and in general condition electric field E naught which is directed positive to negative of plate. Now make it before and after. Okay, for before, for initial condition, suppose we consider charge Q naught, capacitance C naught, potential V naught, electric field E naught, and potential energy U naught. Write it down. The initial charge Qi, that is equal to Q naught. The initial capacitance the initial capacitance Ci, that is equal to C naught, and you know the formula of C naught, the capacitance formula. What? This one, Q is equal to C is equal to half CV square Q square by 2C and half Q into V. Okay, write it down, half Q square by C. Now initial electric field, that is represented by E naught, initial potential, that is represented by V naught, and initial potential energy, that is represented by U naught. Okay, so this is the initial condition. Now after introducing a dielectric slab, what will be the charge? That is the final, what is the value of final charge, QF? Just think one more important point. First of all, when a potential is set up, a potential is charged the parallel plate capacitor, then the potential removed. So when we applied potential in this circuit, then this potential developed here charge plus Q, here charge minus Q. But after removing this potential, the charge remains constant. Why? Because for supplying potential, charge already developed here. So this amount of charge remains constant after removing the potential, after removing the battery. So first of all, the final charge, that means remains constant. So this value remains constant, first point. Now what will be the capacitance? This is the initial capacitance, which is represented by C naught, and you know the initial capacitance formula, epsilon naught A divided by D. Okay, so what will be the final capacitance? CF. We already derived the equivalent capacitance for a parallel plate capacitor with a dielectric slab. That means the capacitance increases K times, that is CF is equal to K into C naught, which is already derived. If you don't watch, go to the previous video and watch it. Okay, now third, that is what is the change of electric field, that is the final electric field expression. And you know the final electric field for deriving the capacitance for parallel plate capacitor. Okay, write it down, the dielectric constant K, that means the initial electric field E naught divided by net electric field, that is E. This is the definition of dielectric constant. Now check one thing here. Here initial electric field E naught, which is directed positive to negative, and EP, the electric field due to polarization, which is directed to positive to negative. So here net electric field E, which is represented by E naught minus EP. So from here you can say the net electric field E, that is equal to E naught by K. So the final electric field, that means electric field decreases K times, that is E final equal to E naught by K. Now when you find out electric field, you can easily find out the potential. So you know the formula for finding potential, V is equal to E into D. So final electric field, so write it down here, the final potential formula, that is final electric field into separation. So final electric field, that means E naught by K into separation D. So what is E naught into D? E naught into D is represent the initial potential, this one. E naught into D is represent the initial potential. So this one becomes V naught by K. That is the final potential decreases how much times? K times. Okay. So this value is constant, charge remains constant. Now capacitance increases K times, capacitance increases K times, electric field decreases K times, electric potential decreases K times. Now finally we have to find out the final potential energy, UF. You write down the formula, final potential energy, that means QF the square divided by 2C. Just check one thing here, the potential energy formula, this one, q square by 2c. So you know the final potential energy value qf that means that remains constant, that is q naught the square divided by 2, and what is c? This c must be the final capacitance, and the final capacitance is equal to k into E naught. So write it down, k into E naught. So this equation becomes 1 by k half q naught square by c, 1 by k half q naught square by c, and this becomes u naught by k, because u naught, that is the initial value, q square by 2c. So q square by 2c is u naught, and there is 1 by k. So here potential energy also decreases k times. So this is the first problem, this is our first problem. So here one important point, that is after removing the battery or cell, the charge remains constant, charge doesn't change. So when charge remains constant, and you know for introducing a dielectric slab, the capacitance increases. It may be battery removed or connected. Okay, then you find out the final potential energy. When the final electric field becomes decreases 1 by k times. So as well as electric potential also increases 1 by k times, and finally we find out electric potential energy, that is also decreases 1 by k times. So one important thing you have to remember here, that is a charge remains constant when battery removed. Okay, now second case, and the second case is battery connected, then the dielectric slab is inserted. Battery not removed, battery charged parallel plate capacitor, and the battery not removed, battery is connected. So this portion is connected. So write it down, this is positive plate, this is negative plate, and this is supplied by battery, connected by battery, and this battery is connected, and this battery developed a charge for positive plate, that is plus q, and for negative plate, that is minus q. Okay, now we introduce a dielectric slab between this separation. Now for introducing dielectric slab, here you have to find out the changes, the charge, potential, electric field, electric potential energy, etc. Okay, write it down, before and after. Same condition, you just consider initial potential, that is V naught, initial capacitance, that is C naught, initial electric field, that is, write it down, initial charge, that is Q naught, then initial electric field, that is E naught, initial potential completed, initial energy, that is U naught. Then you write down the formula. What is V naught? V naught is equal to, you know, that is E naught into D. What is C naught? C naught, okay, not needed here, and Q, and what is this expression? What is U naught? You can write half C naught, half CV square, so half C naught V naught the square. This is the formula. Now you just think, same condition happened here. When you introduce a dielectric slab, there will induce a minus charge, there induce a plus charge, and this minus and plus charge developed a electric field which is named as EP, electric field due to polarization, and there is an electric field, that is E original, that is E naught, which is directed positive plate to negative plate. So the net electric field here, that is E naught minus of EP. Same condition. So here you have to remember one important thing, that is when battery not removed, battery is connected, the potential remains constant, because battery is connected, not removed. So when battery is connected, the basic thing is that the potential doesn't change, potential remains fixed. This is the main function of battery, potential remains constant. So in first case the charge remains constant when battery removed, and in second case when battery connected the potential remains constant. Okay, so first final potential Vf, that is remains constant. So this part is constant. Now final capacitance. What is the final capacitance? That increases. Battery connected or removed, in both cases when we introduce a dielectric slab is always capacitance increases with k times with the initial capacitance. So C final is equal to k into C naught. Now we have to find out final charge. Charge remains constant or changes, decreases or increases. So you know the formula of charge. Q is equal to basic formula, Q equal to C into V. That is, from here we can say Q naught is equal to C naught into V naught. So final QF, that means CF and VF, and you know the CF, K C naught, and VF, that means V naught. So K C naught V naught, that means Q naught. So final charge, that is QF, increases how much times? That is k times with the initial charge. So this part also increases. Now when potential remains constant, obviously electric field also remains constant. You know the formula. So final electric field EF, what is the formula? You know VF by D. So what is VF? VF, that means V naught, remains constant. And what is D? D means the separation, the this thickness of this dielectric slab. Here the dielectric slab is spaced to the entire region, that is the whole thickness. So EF is equal to VF by D. Here VF remains constant, that is VF is equal to V naught by D. And what is V naught by D? This one, V naught by D. V naught by D is represent E naught. So here EF is equal to E naught, that is remains constant. This part is also remains constant. Now finally you find out the final potential energy. Final potential energy formula, half CF VF the square, that is half, and you know the CF, K C naught the square. So this part becomes K square C naught square, and you know this part VF, sorry, this is half CV square, not K square C square, K C naught and VF square. VF square means V naught square. So you can say half C naught V naught square, this one half C naught V naught square, that means U naught. So this part becomes K U naught. So final kinetic energy, sorry, final potential energy, that is increases K times. Okay. So this is our second problem. So what happened here? Here potential remains constant as well as electric field remains constant. Here charge increases K times, capacitance always increases K times in both cases, and here potential energy increases K times. Okay. Now what is the way out for remembering these types of problem? You just think. You know the basic formulas. Q is equal to C into V. So C is equal to Q by V. You just think in both cases C always increases, and how much times? That is K times, K into C naught. Now when battery removed, Q remains constant. Q remains constant when battery removed. When battery connected, V remains constant. V remains constant. Okay. Now you just use this basic formula, then you can easily simplify it. You can easily get that the potential field, electric potential energy changes or not. Okay. So these types of problem is very important for your board exam students. I think it is clear to all of you. So this is all about today class. In next class we will start the next chapter, that is chapter number 3, and it is named as current electricity. So till then, tata, bye bye, stay happy, stay tuned, continue your study.